Hi, my name is Nora Emilia Atira binti Muhammad Hakimi. My metric number 01 DKA 19F 2011. Introduction. Traversing is a form of a control survey that requires the establishment of a series of stations that are linked together by angle and distance. The angle and distance are measured by total station. The use of traversing surveys is very fundamental and has become one of the most common methods in geometric engineering work, such as general purpose angle measurement, provision of contour surveys, contour and detail mapping, setting out and construction work. Objective of this report: first is outline the basic component of a total station. Second, measure coordinate using a total station traverse survey. Third, calculate the bearing and length of every side of traverse after finding coordinate. Next, calculate area of any closed traverse boundary after knowing length and bearing. Last, conduct closed file traverse.
Hi, my name is Nurul Dato Syahira binti Nolizam. My metric number is 01 DKA1 and F 2018. Today, I will present report 2 engineering survey part equipment. First, total station theodolite. Theodolite is a precision instrument for measuring angles in both horizontal and vertical planes. It is used to identify the ground level and the ways to construct superstructure or substructure. Next is tripod. A tripod leg is to support platform for the level. The adjustable leg tripod is easier to set up on uneven ground because each leg can be adjusted to exactly the height needed to find level even on a very steep slope. Next, prism. A survey prism reflects the EDM beam back to its source with both a wide angle of incidence and with high precision. Next, I will explain about the procedure. First, set up total station. All equipment is provided and set up. Second, the place of measurement is identified. Next, the tripod legs are opened and mounted as high as possible. The tripod legs are stepped on to drive to the ground. Attach theodolite to the tripod. Next, theodolite is placed on the tripod and the theodolite is locked properly. Next, centering the total station. Roughly level the instrument using legs of tripod. The total station should stay almost on target. Level with foot screws. Move instrument above target and repeat level and move until done. Next step in total station setup is check the leveling of the circular bubble. Center the bubble using a tripod foot screw. And last, vertical bubble, the leveling is checked and check vertical bubble from all sides. Then center and vertical bubble are checked again. After set up the total station, do the total station face left and face right. First, do the face left observation. From the light's view, target to the back station prism. Second, bearing is set back to 124 to 345 on the theodolite and make sure the measurement distance is 14.088 meter. Next, target to 4 station from theodolite and adjust until get 4 bearing is 155 20 30 and the measured distance is 13.811 meter. After do the face left, transit to find the total station to face right. Adjust and target to back station and bearing face right is set back to 304 2345 and make sure the measure distance is 14.088 meter. Then your target is second 4 station and need to get 4 bearing. Face right is 335 20 40 and make sure you get measure distance face right is 13.810 meter.
Data collection. Based on the data given from figure 1, the distance for line TS is 347 meters and the bearing is 309 degrees, 5 minutes and 38 seconds. For line SV, the distance is 292.94 meters and the bearing is 60 degrees, 21 minutes and 26 seconds. Next, for line VU, the distance is 472.74 meters and the bearing is 128 degrees 4 minutes and 44 seconds. For the last line, which is UT, the distance is 364.55 meters and the bearing is 258 degrees 34 minutes and 22 seconds.
Next, I will continue my friend explain about analysis and data calculation. Okay. Based on this table, okay, how to get the departure and latitude. For example, I give one example that line TS. Okay. Line TS, the calculation to get the departure is distance since its bearing will get the departure for line TS. Okay. 347.00 sin and its bearing is 309 degree 05 minutes and 38 seconds. We'll get minus 269.311 form. Okay, to get the latitude for line TS, the distance cos its bearing will get latitude for that line. For example, 347.00 cos its bearing is 309 degree 05 minutes and 38 seconds. We'll get 218.8158. Okay, so it same goes to all the line, same formula, and you guys will get the departure and latitude for that line. Next, we need to find the enclosure. Okay, based on the formula, just put the value and you guys will get 0.029 meter. And then precision. Okay, precision, the formula is enclosure minus perimeter, and you guys will get the answer is 1.9631 minus 0 power of -5.
Hi, Assalamualaikum. My name is Nurul Nisha Shafika binti Aziz. My matrix number is 01 DKA19 F 2021. Today I want to present about report 2, total station. Analysis and data collection. For line TS, distance 347.00 meter, departure negative 269.3114, latitude positive 218.8158. Correction for departure is 0.0211. Correction for latitude is negative 0.02. Balance for departure is negative 269.3325. Balance for latitude is 218.796. And for line TS, distance 292.94 meters, departure positive 254.6017, latitude positive 144.8854. Correction for departure is 0.0178. Correction for latitude is negative 0.0169. Balance for departure is 254.5839. And balance for latitude is negative 44.868. Line for VU, distance 472.74 meters, departure positive 372.1231, latitude negative 291.5604. Correction for departure is 0.0287. Correction for latitude is negative 0.0272. Balance for departure is 372.0944 and balance for latitude is negative 291.587. And for the last one, line UT, distance 364.55 meters, departure negative 357.3236, latitude negative 72.2258. Correction for departure is 0.0222. Correction for latitude is negative 0.021. Balance for departure is negative 357.3458. And balance for latitude is negative 72.240. And the total for distance is 1477.23 meters. The total for departure is 0.0898. The total for latitude is negative 0.085. The total for correction for departure is 0.0898. Correction for latitude is negative 0.085. Total balance departure is 0 and total balance latitude also 0. How to calculate correction in latitude? For latitude ST, EL times in bracket LTS per perimeter. The value of EL is 0.085. The value for LTS in bracket is 347.00 per perimeter is 1477.23, and the answer is negative 0.02 meters. Correction in latitude SV, ELs times in bracket LSV per perimeter. The value of EL is 0.085. The value for LSV in bracket is 292.94 per perimeter, 1477.23, and the answer is negative 0.0169 meter. Correction in latitude VU, ELs times LVU in bracket per perimeter. The value of EL is 0.085. The value for LVU in bracket is 472.74 per perimeter, 1477.23, and the answer is negative 0.0272 meter. And the last one is correction in latitude UT, ELs times LUT in bracket per perimeter. The value of EL is 0.085. The value of LUT in bracket is 364.55 per perimeter, 1477.23, and the answer is negative 0.021 meter. How to calculate correction for departure? Correction in departure ST, ED times LTS in bracket per perimeter. The value of ED is 0.0898 times LTS in bracket 347.00 per perimeter, 1477.23, and the answer is 0.0211 meter. Correction in departure SV, ED times LSV in bracket per perimeter. The value for ED is 0.0898 times LSV in bracket 292.94 per perimeter, 1477.23, and the answer is 0.0178 meter. Correction in departure VU, ED times LVU in bracket per perimeter. The value of ED is 0.0898 times LVU in bracket is 472.74 per perimeter, 1477.23, and the answer is 0.0287 meter. And the last one is correction in departure UT, ED times LUT in bracket per perimeter. The value of ED is 0.0898 times LUT in bracket 364.55 per perimeter, 1477.23, and the answer is 0.0222 meter. Conclusion. The first one is, balancing the latitude and departure of the track is to try to get the most likely value for the location of the track angle. The second is, a popular fault balancing method is called a compass or Bowditch rule. Bowditch rule designed by Nathaniel Bowditch, surveyor, navigator, and mathematician. The Bowditch method assumes angle and distance have the same fault, an unintentional mistake.